Okay, so here's the third and final part. We're going to look at 19 through the end of the worksheet. This is kind of some of the miscellaneous stuff dealing with compositions and inverses that you could see. So let's talk about this first problem dealing with word problems. So this is asking us to write expressions that represent all of the different discounts and charges that you're going to get going to a Flyers game. So in this case, it's saying that the Groupon that you bought gives you 25% off the cost of the game. So the first problem asks us to write an expression that represents that discount. So remember that 27% off would be 100%, okay, is the cost of originally. We're going to take the 27% off. So when we're actually writing this expression, we're not going to use the 27 directly. We're going to say, when you do this, that there is 73% left, because 73 plus 27 gives me the 100% back. So I'm actually going to pay 73% of the original cost, and I'm going to use that to write the function. So I'm going to say g of x is equal to 0.73 times the cost, which we're using x to represent the cost. Okay, so the second function is saying, let's just look at the second discount, which is the fan membership discount that says $10 off the cost of your ticket. So this is going to be saying, the m function is going to be saying, let's take the cost and let's just subtract $10. So that's a very simple one. Okay, the last one is a convenience charge. So since they're charging us something in addition to the purchase of the ticket, we need to add to the cost. So it's very similar. If I started off with 100%, okay, I'm going to add 3% onto the cost. So the 3% represents how much I'm paying for the surcharge. That gets added to the cost of the ticket, which means my ticket's actually going to cost 103%. So if I write 103% as a decimal, that is 1.03. So I'm going to say c of x, okay, is going to be 1.03 times the cost of the ticket, which we're using to represent x. Okay, so this is the three expressions that represent each discount individually. When we do compositions, it's when we do a bunch of them in a row. So if you remember, we said that when we're dealing with function compositions, we're going to do them in order. So if they're telling us to do the fan membership, then the Groupon, then the convenience charge, I'm going to write down the fan membership first. So if you come up here, it takes m of x represents the fan membership discount. So I'm going to write that one down. Okay, I'm going to take the answer to that, and I'm going to plug that into the Groupon one, which we use g of x to represent that. So I'm going to take the answer to m of x, plug that into g, and then I'm going to take the answer to all of those discounts, and I'm going to plug that into c. So if you notice, I wrote down the first thing they want me to do, and then I kind of built around that to get the other ones. Okay, so let's actually find out. This says actually to write the composition, that is this, okay, and then simplify the expression that would come out of this using what we wrote up here. So this was going to say, let's go to, okay, so the c is going to stay there for a little while. Let's go to the g function and plug in m of x. Well, if I go to the g function, okay, and I plug in m of x, I'm going to plug in an x minus 10 right there for x. So it's going to look like g of x minus 10. Okay, well, if I do g of x minus 10, it's going to be 0.73 times x minus 10. Okay, so 0.73 gets distributed in. Okay, so let's simplify before we plug into c. It's going to be 0.73x minus, if I do 0.73 times 10, I get 7.3. Okay, so now this says take this expression, which represents all of my discounts, plug that into the c function. Well, c says just do 1.03 times whatever you want to plug in. So I'm going to do 1.03 times 0.73x, okay, minus 7.3. Okay, so with this expression, you're just going to do a quick distribute. Again, if you leave it undistributed, it's not incorrect, but we can do a little bit of simplifying here. Okay, so let me move down my page a little bit. If I do 1.03 times 0.73, I get 0.7519. Okay, and if I do 1.03 times 7.3, it's the same expression, but one decimal place over, 7.519. Okay, so I could say if you are taking the Groupon, and then you are also a membership discount, and there's also a surcharge, if we just plug in the cost of the ticket into this final expression, it will do all of that work for you all in one big problem. So that would be the final answer to the problem. Okay, so for the next problems, they're asking us to write the inverses. So we actually did this in one of the other ones. It should be pretty straightforward. Okay, so I'm going to say switch x and y. That's how I algebraically write inverses. So I'm going to say x is equal to 1/2 y plus 8. Okay, so I'm going to resolve this for y. So I'm going to subtract 8 over x minus 8. Okay, and that equals 1/2 y. Okay, and then to get rid of a 1/2, the easiest thing to do is just to multiply by its reciprocal, which is 2 over 1, which just means multiply by 2. So this is going to become 2x minus 16, and that equals y. So I would say the inverse of letter A is going to be 2x minus 16. Okay, letter B is the same thing. I just want to remind you that f of x and y mean the same thing. So when I do the switch, I can replace this f of x with a y. So this is going to look like x equals 2y minus 5. I'm going to add the x over. Add the 5 over to the x. Okay, and that equals 2y. And then I'm going to divide both sides by 2, and it's going to look like x plus 5 over 2 is equal to y. And again, just a little side note, if you choose to actually say there's a 1 here, you can turn these into fractions and say this is 1/2 x plus 5/2, or the decimal versions would be fine as well. Okay, so I could say either of these answers, right? They're both okay. You don't have to have both, just one or the other. Okay, so my last problem, again, very similar. Switch x and y, and then we'll resolve it for y. Okay, so to get y squared alone, I'm going to subtract 5 over, and then I'm going to square root. So here's the one little reminder about this. When I square root, I get two versions. So I'm actually going to say the square root of x minus 5, but don't forget that there's a plus or minus out here. Okay? So I'm going to say that the inverse of y equals x squared plus 5 is going to be this expression here. And again, you might see show up in the problem, I could call it f inverse of x. This is the notation we use to represent something like f of x. Its inverse is f inverse. So I might say that this expression over here is actually f inverse of x. So you might see that show up as well. Okay, here's your last 3 inverse problems. A little bit more work involved with these ones, especially letter G. So your last 4 of them. Right. So problem number letter D, we're going to say switch x and y. So I'm going to say x is equal to y plus 3 squared. And I need to get y alone. So the first thing I'm going to do is square root. And again, when we square root, it's actually plus or minus the square root of x. So just be careful that you are doing that plus or minus. Okay. And now that I square rooted the right hand side, it's just y plus 3. And when I subtract 3 on both sides, it becomes negative 3. So it's really negative 3 plus or minus the square root of x. And that is y. Okay, that is the inverse. So again, not that nice of an answer, but that is what they were looking for. Okay. Letter E, let's switch again. It's going to look like x equals the square root of y minus 2. In order to get rid of a square root, I'm going to square both sides, so it looks like x squared now. Okay, and then I just need to add the 2 over, and y is alone, so it's x squared plus 2 is equal to y, and that would be my inverse. Okay, problem number letter F, same idea. I can't square. Well, let's do switch first. I'm going to say x equals the square root of y plus 8. Okay. I can't square the y, the square root to get rid of it until I move this 8 over. So in this case, I have to say x minus 8 equals the square root of y. And here's where you got to be careful. Okay, I'm going to square the right-hand side, and it becomes y. When I square this, it's x minus 8 squared. Okay, and then I'm actually going to square it out. So this is going to become, again, not x squared and 16. It's going to become x squared minus 16x plus 64. Okay, so make sure you square. Don't just square the parts and get an x squared and a 64. Do x minus 8 times x minus 8, and you're going to get x squared minus 16x plus 64. That would be y. Okay, so this last one's actually pretty tricky, so let's talk about this one. So we're going to switch x and y. Both of these x's are going to turn into y, so it's going to look like x equals y squared plus 6y minus 3. Okay, and I'm looking at this and saying, all right, I'd like to get y alone, but my problem is that there are 2 of them on the right hand side, and in my final answer there needs to just be 1. So I got to find a way to fix that. Okay, so here's how we do it. Let's get this minus 3 out of the way, okay, and move it to the other side. X plus 3. This is actually going to be a completing the square problem. If you remember completing the square problems, we always took, and this is an unrelated problem, I'm just going to show you an example. We always took this example, okay, and we said I can turn this into x plus 2 squared, right? So this is an example where we're converting an expression that has 2 variables in it, right? There's x showing up twice, and I can convert it into a form that only has 1. That's the problem that we're trying to fix here. We're trying to get rid of the 2 y's that are showing up, and we're trying to turn them into 1. So if I complete the square here and say, well, 6y, well, let's take the 6 and divide it by 2. That's a 3. Square that, I get a 9. So I'm going to add 9 to both sides. Put a plus 9 here, and I'll put a plus 9 on the other side as well. So now it looks like x plus 12 is equal to y squared plus 6y plus 9. Okay, and I did that because now this right-hand side turns into y plus 3 squared. Okay, this is 3 times 3. 6 is 3 plus 3. Okay, and I can finish up my problem. In order to get the y alone, I'm going to square root both sides. So the square root of x plus 12 is going to be plus or minus, again, okay, x plus 12. And now I square rooted the right-hand side as well, so it's just the y plus 3. And now I can subtract the 3 over, and it becomes negative 3 plus or minus the square root of x plus 12. Okay, so this is a trickier problem because the method that we have to use to get y alone is completing the square. And all the other ones we just had to solve using add, subtract, multiply, divide, and square roots. So this one had a little bit more work involved. It's a trickier problem, but we did what they asked us to do. We switched x and y. We got y alone again by itself, just one of them. And I would say this expression, negative 3 plus or minus the square root of x plus 12, is the inverse of the original expression. Okay, so that's a little tricky, but it's complete. All right, last few problems. Okay, in each of these, they're asking us to verify that f and g are inverses using compositions. So what that means is we need to do two things. Okay, so for this first one right up here, problem number 1, I'm going to say f of g of x. Let's check that. Let me finish. Okay, f of g of x, okay, is going to be f of, well, g of x is x minus 6, okay, which is saying go to the f function, plug in an x minus 6, so that's going to look like x minus 6 plus 6. Well, that's just x, and that's good. This is what we're looking for. If two functions are inverses, when I do compositions, all of the operations should go away, and the only thing that's left is x, whatever the variable is. Okay, so let me do the other way around. It has to work in both directions. If I take the g function and I plug in f, the same thing should happen. So this looks like g of x plus 6. Okay, x plus 6 is my f function. Okay, well, this says go to the g function, plug in an x plus 6. So I'm going to say x plus 6 minus 6, and the same thing's going to happen. I'm going to say this is going to be x, right? Plus 6 and minus 6 cancel. Okay, so you can do that for any of these problems. I'm only going to do one more. I'm going to do the one right below it because it's got some fractions in it, but all the rest of them pretty much simplify the same. Right, so I'm going to do this one. I'll call this one number 2. Okay, so problem number 2 here. Same idea. F of g of x is going to be f of, well, g of x is this thing, so I'm going to say negative 1/3 x minus 3. And that means let's go to the f function, negative 3, and instead of writing x, I'm going to write what they asked me to plug in. Okay, so here's what we guys got to be careful. Negative 3 times negative 1/3 is actually 1. So this becomes 1x. Negative 3 times negative 3 is positive 9. Okay, and there's my cancel happening, and I just get x. Good, that's what I was looking to have happen. Okay, let's try g of f of x. That's the opposite. Right, and this is going to say let's go to the g function and plug in negative 3x minus 9. Okay, so same idea here. I'm going to go to the g function, and it says do negative 1/3 times x. Well, our x is this thing. Okay, and then subtract 3. Okay, so I'm going to say negative 1/3 times negative 3 is still 1x. Negative 1/3 times negative 9 is going to be a positive 3. Minus 3. There's the cancel happening again. So I can confirm that these two functions are inverses because I did f of g of x and I did g of f of x, and in both cases all the operations canceled and my final answer was just the variable. So that one, these are both good functions. So for these other two on the right, it's the same kind of thing. You're just going to have to simplify the numerator in each of them before you cancel. Okay, so I'm not going to do those problems because they're very much the same. Okay, so let's talk about the last one, which is dealing with graphs and inverses. So in this problem, it's asking us to graph the inverse on the same graph. So if you remember what the definition of inverse was, we said switch domain and range. So when we're talking about graphs, the domain is the x values, the range is the y values. So I'm saying if you want to do the inverse, take all of the points that are x's and y's and turn them into the switched version. So I'm going to take my list of points and I'm going to write it. So for this particular graph, the original function, I'm going to say my points are negative 2, 3. I see a negative 1, 0. Okay. I see a 0, negative 1. I see a positive 1, 0. These are the ones that they marked. And I see a 2, 3. Okay, so for this parabola, these were the 5 points that came out to be nice grid points that they marked for us. Okay, if I'm doing the inverse, I'm going to take each of these points and I'm going to switch the x and the y because that's what the definition of inverse is. The domain and the range get switched. So the points that I'm going to graph for the inverse are 3, -2, 0, -1, -1, 0, 0, 1, and 3, 2. Okay, so I'm just going to go to my graph and I'm going to put those points down. 3, -2, okay, 0, -1, that's already marked, that was on the original function. -1, 0 also was marked, okay, 0, 1, that's this one, okay, and 3, 2, okay. So if you notice, it's the exact same parabola, but it's kind of rotated clockwise 90 degrees, and that's the way inverses work, okay. So I'm going to say, in this case, see if I can draw myself a nice graph here, that this is the inverse, okay, on the graph, okay. And if you remember, we said that if I draw a dotted line, write down y equals x, which is the diagonal going from the bottom left to the top right, that it's actually a reflection right over that. And if you notice, I have points that are an equal distance. This point right here is like a half a block above and to the left. I have a half a block above and to the right. Okay, and the same thing with all of these. This one's about a half a block and a half a block. All right, I have some that are really far away. This one's probably like 4 blocks away, but I have another one that's right over here 4 blocks away too. So they're the same distance on either side of that line. Okay, so let's just answer the questions about this function, and then we are done with the review. Okay, it says, is problem number 22 a function? We're going to say yes, it is a function. It is a function because it passes the vertical line test. So let's just show that. Right, here's my vertical line. Okay, the vertical line test says that I should be able to drag a vertical line across this anywhere that I want, and I will only ever hit the graph once. And if you notice, there is no spot along this picture that I'm going to hit it more than once. So I'm going to say yes, it's a function because it passes the vertical line test. Okay, so let's get rid of that. Okay. Number 22 says, is this a one-to-one function? To check to see if something is a one-to-one function, I'm going to do the horizontal line test. So there's my horizontal line. And you can see right here, I don't even need to move this. I am hitting the graph twice with a horizontal line. So what I'm saying is, no, this is not a one-to-one function, and I know this because it fails the horizontal line test. Okay, the horizontal line test, in order to pass it, you can only ever hit the graph once, just like the vertical line test. So I'm saying, no, this is not one-to-one because it fails the horizontal line test. Okay, here's the last question. Okay, the last question says, what does that tell you? Okay, in problem number 20, this says 25, this should be 24. Okay, in problem number 24, okay, we figured out that that the graph above was not one-to-one, and they asked, what does that tell you about the inverse of the graph? Okay, what that tells us is that the new graph, this blue one, is not a function. Okay, so we don't even need to do a graph if we didn't want to. We could look at that and say it fails the horizontal line test. That means it's not one-to-one. Because it's not one-to-one, we can say that we know that the inverse of this function is not a function. And we can actually confirm that by looking at the blue graph. If you take a look at the blue graph, it's going to fail the vertical line test, so it's not a function. Right? The horizontal line test and the fact that the original graph is not one-to-one tells us the exact same information. Okay, so this is really just dealing with whether or not inverses of functions are still functions. Because this one is no, it is not one-to-one, we would say no, it is the inverse will not be a function. Okay, and that's the end of the video review. Okay, so there's 3 parts. Hopefully you were able to get all your answers out of all 3 of those parts.